So here we're told that secant of theta is equal to 4 over 1, and we're supposed to find all the other trig ratios. So we need to find cos, we need to find sine, we need to find tan, cosecant, and cotangent. What strategy do you think we should use? Draw a triangle. Yes! Well, it might be a little bit hard to draw a triangle with secant theta equals 1/4, but if you know secant, you know cos. So you know that cos of theta is equal to 1 over 4. Now, if it's between 0 and 180 degrees, and cosine of theta was 1 over 4, what quadrant is it going to be in? What quadrant is it going to be in? If I want to draw my triangle, I better draw it in the right spot. It's going to be in the first quadrant. How do you know it's going to be in the first quadrant? Cos is positive. Cos is positive according to the CAST rule in quadrants 1 and quadrant 4, but we're only looking between 0 and 180 degrees. So we're only looking in quadrant 1 and quadrant 2. So then the only place it could be is in quadrant 1. Good? What can I label on this triangle? How long is the hypotenuse? Yes. No. Close. 4. Whew. Where's the 1 going to go? Adjacent. So which is the adjacent? Because I have no angles labeled here. It's going to be the x-axis because this is our reference angle. So we're always thinking about our reference angle to the nearest x-axis, and that's what we're going to be basing what we label things on. Now quick, in your head, a squared plus b squared equals c squared. What's the other side? Square root of 15. Because the hypotenuse, 4 squared is 16, minus 1 squared will give me 15. So now that we've done that, how hard is it to find sine of theta and then cosecant of theta? Well, sine of theta will be square root of 15 over 4. That means cosecant theta will be the reciprocal, 4 over the square root of 15. Tan of theta, opposite over adjacent. That means cotangent. And since everything is positive in quadrant 1, these will all be positive. Now, to the nearest degree, find all possible values of theta between negative 360 and 360. So what they're basically asking us to do is solve for theta, right? We're supposed to, in part B, to the nearest degree, determine all possible values of theta. So this is our job. How did we do this in grade 11? We used reference angles. We had to start with an equation. And how many equations do we have? We have 6 different equations. Doesn't matter which one you pick, they will all give you the same answer. I would recommend not choosing cosecant theta because you're probably not as comfortable with that as you are choosing sine, cos, or tan. So let's pick one, sine, cos, or tan. Tan. So if you chose tan, now we're going to show you that if you chose cos, it's going to give you the same thing. Then if you chose sine, it's going to give you the same thing. But we chose tan, so we're going to start off with tan of theta is equal to the square root of 15. Actually, we should technically choose cos. Okay? But Because the question originally gave us secant. Now, when we drew our first picture, we only drew it in quadrant 1, right? Because in quadrant 1 is where cos and secant are positive. Where else are cos and secant positive? Quadrant 4. If we chose tan, we're going to get it positive in quadrant 1 and quadrant 3. So we're going to run into some problems there. So yes, technically it's going to be best. I'm sorry. Everybody wrote tan. Everybody's going to be mad at me. Technically, it's best to start with cos. Still wouldn't matter if we chose cos, tan, or sine to get our reference angle, but it's going to be important that we chose cos because we were given that to begin with, and because it's positive, we know that our answers are going to be in quadrant 1 and quadrant 4. So what we did in grade 11 is when we wanted to solve for an angle, we had to do the opposite of cos. Because right now it's cos of theta equals 1/4. And to get rid of the cos, we have to do what's the opposite of cos? Cos inverse. So technically, if you take cos inverse, and nobody writes this, but we could. If you'd write cos inverse of both sides, cos inverse and cos go away because they're inverses of each other. You're just left with theta is equal to cos inverse of 1/4. But for whatever reason, most mathematicians don't write the cos inverse on both sides. They just write cos inverse is equal to 1/4. And then you type that into your calculator, and we get a value. What do we get? $75.5. Does it say to the nearest degree? To the nearest degree, that would be 76 degrees. That technically is our reference angle. So if our reference angle is 76 degrees, and it can be in quadrant 1 or quadrant 4, what are our answers? Well, in quadrant 1, it's also going to be 76 degrees. What's it going to be in quadrant 4? Sometimes it's helpful to draw a picture out. Draw a picture out with a reference angle of 76 degrees in quadrant 4. What is this angle going to be? 360 minus 76. 360 minus 76 is 284 degrees. So what's going to happen in a lot of these questions is you're going to solve between 0 and 360 first and feel like, good, I've solved everything I need to. But before you move on, you're going to go back to your question and say, have I solved it over the domain that they asked me for? Because generally, most often, they'll ask between 0 and 360 degrees. Did this question ask between 0 and 360? No, it asked between negative 360 and 360. So we were able to hit 76 degrees, that would be right here, and 284 degrees, that would be right there. But now we also have to look at the negative angles. What angle would this be if I ended in the same spot, coterminal with 284, but going in the negative direction? That one would be negative 76 degrees. And what angle would this be if I went in the negative direction and ended in the same place as 76 degrees? Negative 284 degrees. It doesn't always work that if you get your answers the first time that your answers in the next ones are negatives. Depends on which quadrants they are. But in this case, they happen to be the same, just negative values. Okay, the questions you can do are 9, 10, and 11.